Good morning. Am I audible? All of you can listen. Okay, thank you. Suraj, Niranjan, Devashish, you have joined. Devashish, your problem is resolved now. Mirza Adil. I started my camera. Video, I guess it is now visible to all of you. Yes. So Devashish might be feeling relief now. He was facing some problem for the login in the earlier sessions. So that's good. The problem is resolved. So I can see that along with me, there are 7 participants, 7 number of the people have joined as such. We'll wait for some 2-3 minutes, and then we can start with the today's discussion. I hope that the syllabus for the power plant engineering that I posted 2-3 days ago, you might have definitely gone through the syllabus. We have discussed the various contents of the syllabus from unit number 1 to the unit number 5 in the earlier session, last lecture, in Monday's lecture that we discussed. The teaching evaluation scheme that was also elaborated to all of you. The practicals which are involved for the power plant engineering laboratory that we discussed. The different textbook which you are supposed to use for the study purposes as far as our subject is concerned, that also I have to. And I would like to remind again that the course in the power plant engineering by Dunkun and Arora. Okay. Course in power plant engineering by Dunkunwar and Arora. So that is one of the best book which covers almost syllabus for all the topics. I would say 95% of the topic may be definitely covered, or rather are covered in the book by Dunkunwar and Arora. So I will definitely recommend all of you to go through that book. And once we are finishing this particular unit number 1, so I will be also posting the PowerPoint presentations to you on your group as well, so you can have for your ready reference. That is one thing. And the second thing is that the recording for the earlier sessions, okay, the previous lecture, that also you can see on the next day. Okay, so the Monday's lecture that we conducted, so that was available for reviewing, I will say, from yesterday. So similarly, today's lecture, those who have missed or those due to some technical reasons, so they can review this particular lecture from tomorrow onwards. Okay. So 18 students as such joined: Virendra, Kunal, Omkar, Nikhil, Nachiket. I will share my screen to all of you, and once I share the screen, I only see what the things are there on my desktop, and as such I assume that you are quite attentive enough behind the screen or on the other side of the screen, because it is a virtual one, so it is not possible for me to view everybody, but I can see the names there. Okay, so you take a notebook and pen along with you, and if you feel some important points that can be noted, that should be noted, you can note down those in brief. That is one thing. And in the coming sessions, maybe in the beginning of the next week, we'll be dealing with some of the numericals for the unit number 1. specifically for the second part of our unit number 1, that is nothing but the economics of the power generation, which involve the calculation of the cost of the electrical energy. So different methods are there which are used for this calculation. So definitely from the next week onwards, along with the notebook and pen, I will suggest that you should keep your calculators with you as well. So it is better for you to make the calculations, and you can cross check the answers with what that I am having and what the calculations that you are having in your notebook. Okay. So to be attentive enough, and I know that all of you are being quite honest as well. So definitely you are going to listen, and any as such difficulty that you face, so don't hesitate to raise that one. Okay. Rakesh, you have joined. So Rakesh was also uh, facing some problem to join the different sessions. So I hope that the problem for the Rakesh is also resolved. Yes, good morning. That's good. Okay, so henceforth I will suggest that you attend all the lectures positively, and if any technical reasons are there, you face the problem. So please let come to know to your batch mentor first, and then the suitable steps would be taken to resolve your problem. Okay, I will share my screen now. So I guess that this screen is visible now, and I can start with the discussion for the today's lecture. We'll just recap the things that we have seen in the last 10-15 minutes of the previous section, previous lecture rather. We have seen that the energy is nothing but the engine of the growth, isn't it? Engine of the growth for the economy or a sustainable growth of any particular nation. So larger being the availability of the energy, and larger the consumption of the energy. So that definitely indicates or highlights the quality of the life or the standard of living of that particular nation. So that was the one of the important point that we came across in the earlier lecture. Then we have enlisted the different types of the power plants which are available for the generation of the electricity, and we also made one point to note that electricity is nothing but one of the cleanest form of the energy that is available for the end user or the consumer at the last end. So these were the types of the power plant that we listed in the last session, last lecture. Conventional types and the non-conventional types. Conventional types that uses the conventional fuels, fossil fuels we will say, like that of the oil, or you may have the gas, you may have the coal, or you may have such kind of fossil fuels rather I will say, nuclear fuels as well. And such types of the power plant are listed as thermal power plant, also known as the steam power plant, diesel electric power plant. So definitely it uses the diesel cycle that you learn in the applied thermodynamics, constant pressure cycle. Gas turbine power plant. If my intuition is correct, you might have learned in the subject of the turbo machines, the gas turbine power plants that you have studied, isn't it? Preliminary information definitely might have been discussed for the gas turbine cycle rather I will say, isn't it? So nothing but the Breton cycle or the Joule cycle that is used for the operation of the gas turbine power plant. So whenever we say these three types of the power plant, so you must be aware with which thermodynamic cycle is used for its operation. So thermal power plant that uses the Rankine cycle, diesel power plant. So the name itself highlights it uses the diesel cycle, gas turbine power plant that uses the Breton or the Joule cycle. And if the cycle is reversed, the reverse Breton cycle or the reverse Joule cycle, so that we have seen in the refrigeration and air conditioning while studying the topic of the aircraft refrigeration cycles of the systems, isn't it? So that is a reverse cycle using the refrigeration purposes. Hydroelectric power plant. So you might have studied some of the different types of the turbines used for the operation of the hydroelectric power plant in the turbo machines in the third year. Nuclear power plant that also makes use of the same cycle that used in the thermal power plant, which is nothing but the Rankine cycle. And lastly, nothing but the combined cycle power plant. So which makes the combination or the two cycles are combined with each other and they are running in tandem with each other. They are synchronized so that the output of or the waste of one power plant can be used as an input or the energy for the other power plant. And the most preferred configuration or the arrangement for the combined cycle power plant is nothing but the combination of the gas turbine power plant and thermal power plant. So the exhaust gases which are leaving the say gas turbine power plant may be used for the operation of the thermal power plant to generate the steam from the water. Okay, so that way we can have the list for the conventional types of the power plants. And coming on to the non-conventional power plants, solar thermal power plant. So it is nothing again a solar thermal. So it means that it uses the same cycle, that is the Rankine cycle. If you feel the names of the cycle that are important, you can definitely note the names of the cycle at your end. MHD power plant, magneto hydrodynamic power plant, biogas, biomass power plant. You can see such types of the plants normally they are in the rural region, rural areas. Geothermal power plant, ocean thermal tidal power plant, and the coastal region, and the wind power plant, which makes the use of the windmill or the wind turbine to convert the rotational energy into the mechanical, and the mechanical energy is further converted into the electrical energy. Okay. So that is what the background that we had in the last lecture when we started with the unit number 1 of the power plant engineering. Okay. As far as the initial part for the today's lecture that is concerned, so we will be discussing the roles of the different say the sectors which are involved in the generation of the power. So that may be at the national level, that may be at the state level, and the different players, different generation companies which are involved in this business, the power generation, power distribution, and selling of that power to the consumer. Okay. So that will be the initial part of the discussion for the today's session, and if the time permits, we'll move for the further points for the discussion. So there are the three major pillars or the three major sectors which are there in the power generation industry. Now this particular entire power generation industry, so that has been say trifurcated, I will say. It is divided into the three different parts, and each of these parts are given a specific responsibility that can be played in that region only, like that of the you are limiting your business only for the generation of the power. So power generation company, power transmission company, and power distribution companies. So that is nothing but most of the state electricity boards are now trifurcated in these three sections: generation, transmission, and distribution. And for this generation, transmission, and the distribution, so sectors can be divided as a central sector, which is normally handled by the Ministry of Power at the by the central government of India. Then the state sector, which are normally handled by the State Electricity Board. Each of the state may be having their self-installation, their state-owned companies for the generation, transmission, and distribution. So state electricity boards, which are normally operating at the state level to satisfy their demand. And if they have the capacity for the say the excess power generation, so they also sell the excess energy generated to the neighboring states. Then the private sector also plays a major role in the generation, transmission, and the distribution of the energy. Now we'll also discuss that what is exactly the role or why the significance is there for the private sector, why the boost is required to be given for the private sector as far as the generation, transmission, and the distribution of the energy is concerned. One fact is very clear that we can say that the demand for the uh, energy, so that will be ever increasing. So there won't be any as such situation that you can have the demand of the energy has been reduced drastically. Demand of electricity has been reduced drastically because as you are say moving ahead, you are progressing ahead in the different sectors of the economy. So definitely your requirement for the energy, not the consumption, so that will go on increasing. So private sector is the one which is having the one of the good potential, major potential that can play a lion's share in the power generation, transmission, and the distribution. Okay. So that way we will be say moving our discussion for these three sectors: central sector, state sector, and private sector respectively. So we have discussed up to this particular slide in the last session. So that's why we have taken the reference for the last 10 minutes. The Central Power Corporations of India. So these Central Power Corporations of India are nothing but these are the companies which operate at the national level. Okay, they are involved in the selling of the electricity at the national level, and if that particular region uh, generates excess energy, then it is also supplied to the neighboring countries as well, isn't it? So likewise, if we see there in the northern part of the India, so some of the excess energy generated is also supplied, is also given to the neighboring country, that is the Bhutan. Part of the energy is supplied to the Bhutan island. So out of the total generation capacity at the national level, which includes both, I will say, the energy which is generated by the central sector, energy which is generated by the state sector, and the energy which is generated by the power sector. If we combine energy generated by all these three players, if we account it for 100%, so nearly 1/4 or 25% of the energy is generated by the central power corporations or companies at the national level. So these are the different companies. Now the list may not be only restricted to this 6, 7, 8 that I have listed here. So there may be even more as well. You can add in that list with the more survey on the different companies at the national level. But these are some of the key players I will say. National Thermal Power Corporation (NTPC). Now NTPC is also not only involved in the generation of the power, but it is also involved in the training of the personnel, training of the people, which can be absorbed for the operation of that company itself. So you may visit the websites of these different power generation companies, because these power generation companies recruits a lot of mechanical engineers for their operation. So you may have definitely a good scope to work as an engineer, as a mechanical engineer, to play the role of mechanical engineer in these different public sector undertakings which are owned by the government of India. Okay. NTPC, NHPC, NPCIL. So all these companies are conducting their own entrance test. So you should go to the syllabus of the entrance test for these different companies, and you can definitely find out what scope that you may have in these companies. Okay. So I will move on to the next slide. Having discussed there onto the state, that is nothing but the central sector. The second is nothing but the state sector, the state electricity board. So besides the PSU, that is public sector undertakings, like that we see listed in the earlier slide. So several state level corporations are there which accounts for 28% of the overall generation. We have seen that the central sector that accounts for nearly 25% of the electricity, so slightly higher than that one. It's 28% of the overall energy is generated by the different state electricity board, and the requirement of that particular states are satisfied by this state electricity board. Some of they are say mentioned here. Each of the state would be having their own electricity company, own electricity board, and each of these boards are now divided into the three different companies. They are trifurcated. That, as I mentioned at the beginning of the session. So as far as the Maharashtra State Electricity Board is concerned, we are very much aware that we are having the three companies which operates at the state level as far as the Maharashtra is concerned. So Maharashtra State Electricity Generation Company Limited, Maharashtra State Electricity Transmission Company Limited, Maharashtra State Electricity Distribution Company Limited. And likewise, uh, in the central corporation, central companies, there is recruitment for the mechanical engineers. So on the parallel lines, you can also play your role as a mechanical engineer in the different companies which are owned by the state electricity board. Okay, so I will also suggest to go through the sites for these three different companies for the state electricity board. Whereas the Gujarat State Electricity Board, so that is involved in not only the generation but the intra-state distribution of the electricity as well. Okay, so it is supplying their excess energy to the neighboring states, maybe say Madhya Pradesh, maybe the Maharashtra, or maybe the Rajasthan as well. Okay, so substantial role is played by the state sector as well, state electricity board as well in the generation of the electricity. Coming on to the third sector, a major important one, the private sector. There would be some limitation, there would be some constraints, not only for the state government and the central government to expand their infrastructure in the power generation, because the rate at which the energy consumption that increases and the rate at which you are creating the infrastructure to meet this gap of the supply and demand. So the efforts made by the state government and the central government may not be sufficient. So you may be facing, say, the lack of the power or the non-availability of the electricity, specifically in the rural region, rural areas, so which are majorly dependent upon the agriculture for their livelihood. So why not we can involve the third party and let them use the resources they are having available or the capital that may be available with them, and give them a boost so that they can play a major role in the generation and selling of this electricity. Now, this generation and selling of electricity that should be there in the at the competitive price, competitive rates as well. Okay, some rational price should be decided. So, taking into consideration such things, such parameters, the private sector companies are given a boost. They are given a platform that they can play a major role. So that is what it is stated there in the first paragraph. Other than public sector undertakings and state level corporations, state electricity boards, private sector enterprises also play a major role in generation, transmission, and distribution. Now, over the last few years, definitely the momentum has been gained by the private sector, and out of the total energy generation capacity, capability, so nearly half, 47% is produced from the private sector. So it is 1,73,950 megawatt. So nearly close to 1,74,000 megawatt. So half of the energy which is required for our country is generated, transmitted, and distributed by the private sector. So it plays a very big role. It shares sizable contribution at the national level. Whereas this Power Grid Corporation of India, okay, again that is a company which is responsible for the interstate transmission. It means that you take the energy from one state, transmit that energy to the other state, isn't it? So it is nothing but a mediator which can act between the two states. Take the electricity from one state, transmit that one, and make it available for the other states. So that normally operates at the national level. So this Power Grid Corporation of India Limited is responsible for interstate transmission of electricity in addition to development of the national grid. So that is involved in making a grid or making a web so that wherever you are say producing the excess energy, so you can extract that one and let it be supplied to some other remote place where there is a scarcity of the electricity. Okay, so that role is played by the Power Grid Corporation of India Limited. And if you see there in the last slide, some of the key players in the private sector are mentioned. There may be many more as well. So some of them are highlighted here. Tata Power, very well renowned, that we know that the Tata Hydroelectric company, they are having their plant near to Lonavala, that we can say, or near to Khopoli. Reliance Energy, so they are having their gas-based power plant at what you can say, the Dahan. Jindal Energy, so they are having their plant near Ratnagiri, gas-based rather. Adani Power and Torrent Power. So these are some of the recent, we would say, the private players which are involved in the generation, transmission, and distribution of the electrical energy at the state level as well as at the national level as also. Okay. So we came across the three different sectors: central sector, companies which are owned by the government of India; state sector, state electricity boards which are under the purview of the that particular state government; and third one is nothing but the power sector. Okay. So let us see why the power generation companies, specifically in the power sector, are given the boost, or what exactly the policies are being framed by the government, so that the scarcity of the power can be overcome by giving boost to the power private power sector rather. So the Electricity Act 2003, so that made the number of amendments, and it uh, turned out to be the major point or the turning point, and which incorporated the different reforms and some of the key points that I have highlighted in this particular slide, so that the private sector may be encouraged to play their role in the power generation, transmission, distribution. Remove the need of license for the power generation project. Encourage the competition through the international competitive bidding. Okay, so that is very important one. The private sector or the private company which gives their bidding or which gives their proposal at the competitive rates. So that is the major concern which should be taken into consideration. Identified the transmission of power lines as a separate activity, because rather at the beginning it was only the generation, transmission, and distribution was carried out by a single entity only. So that involved a lot of what you can say, the administrative and the logistic problems that might be say facing till the energy reaches the end consumer. So they identified the need for the separate company, separate activity for the transmission of the power lines. So Power Grid Corporation of India, that I will say, and invited public and private sector to play their role in the transmission of the power lines. The private sector who can develop the power plants which are in the capacity is more than 1000 megawatt, or we can say the mega power project, we can say capacity in excess of 1000 megawatt. So they were given some concessions like that of the benefit for the tax holiday, a concession in the taxes for the 10 years out of the 15 years of their initial operation. Okay, so some concessions are given there so that they can provide the energy at the cheaper rate, at the competitive rates to the consumer. One of the important reforms or the recommendation was nothing but this particular Electricity Act that allowed 100% foreign direct investment. So the financer which is having the handful of the capital with him, so he can have the 100% of the direct investment in that particular sector, in that particular project rather. And selling bulk power to the grid or the other personal. It means that if a private company that produces the entire power, and instead of having their separate transmission and the distribution line, so what they will do, they will simply sell the power to the Power Grid Corporation of India Limited. Okay, so it is nothing but the business between that particular power company and the Power Grid Corporation of India Limited, or between the direct end user. Rest of the things are left with the Power Grid Corporation of India, that is transmission and the distribution as well. So that way, the chain would be say, operating for the private sector. Then the waiver of the imported duty on the capital goods needed for the mega power projects which are having the capacities more than 1000 megawatt. It means that whatever the uh, infrastructure that you need, or the machineries, heavy machinery that I will say, which are required for the installation of that plant, mega power plant. So most of these machineries are imported. Okay? And government of India uh, so provides the import duty for such machineries. So they are being completely waived off so that the cost of purchase of those machineries can be reduced, and which will in turn reduce the cost of installation, and at the cheaper rate the energy can be made available for the end user or the end consumer. So this energy electricity act, so that ought to be the turning point in the reforms as far as the private sectors are concerned. Okay. Now that was, I will say, the one of the part for the unit number one. Uh, in coming few slides, we will be discussing about the scenario, the power generation and the power consumption scenario, uh, the trends or the patterns those can be observed over the last few years at the three different levels. One, that is nothing but at the global level, second at the national level, and third that is nothing but at the state level. Okay. Now, this is one of the particular trend which can be seen there, which gives the information about the trends in the energy consumption in terawatt hour per year. TW stands for the terawatt hour per year. So on the y-axis, the numbers are given there for the energy consumption in terawatt hour per year, and along the x-axis, it is a time period. So we can say from 1965 to 2015. Uh, Maybe a slight change would be there in the last 4 or 5 years. We can say this is nothing but a summary for the last 50 years. So trends which can be observed in the last 50 years. So these energy consumption trends are shown for the different types of the fuels. What fuels are being say highlighted here? The oil, the fossil fuel, oil, then the consumption trend for the coal, then gas, the energy consumption which is there from the nuclear sources and from the renewable sources. So this blue color trend, so it can be seen there for the oil, isn't it? So largest energy consumption requirements are satisfied with the fossil fuel that is available in the form of the oil at the global level. And we can see that the from 1965 to somewhere in the mid of 1980s, okay, from 1965 to the 1980s, this requirement was been say ever increasing. Okay, it has reached to the peak. It has reached to the peak around say 35,000 terawatt hour per year, somewhere nearer to the 1980. Is that fine? And there has been a slight drop from 1980 to the 85. Okay, so there is a drop in the uh, consumption pattern as far as the oils are concerned. And from 1985, we can say that it is linear. So there are very less fluctuations in the trends which are say observed for the energy consumption as well from the oils are concerned. So we can see from 1985 onwards till we reach to the 2015. So almost linear variation is observed. Okay. The very small, what you can say the variations. Okay, so it's a linear trend can be seen there, straight line trend. Then for the coal, so it was more or less a similar one that is shown by this black colored curve from 1965 to 1985 or somewhere 90, it was observed to be almost the linear one, dropped to a slight extent, and then again from 2005 onwards, it have increased drastically. Maybe some new reservoirs are being say discovered for the coal, and coal forms to be one of the cheaper alternative, cheaper fuel, fossil fuel that is available for the mankind, isn't it? So that's why the trend in the consumption of this coal can be seen drastically increasing from 2005 onwards till the 2015. So that has been increased over the last 10-15 years. But we know that this coal and oil, they are not going to last there for more than 25 years, 30 years down the line, isn't it? Within 25, 30 years, these are going to get depleted, and we must go there for some alternative. The third trend is there for the energy which is say available from another fuel source, that is nothing but the gas. So it is seen that for the gas over the last 50 years, so it is almost linear. So no major fluctuations, no major ups and downs are seen there for the trends or the energy consumption pattern as far as the gas is considered as an fuel, isn't it? So from 1965 to the 2015, so it is almost a straight line curve that can be seen, isn't it? So these three fossil fuels, the oil, coal, and gas. So these fuels satisfy the major requirement of the energy consumption across the globe, isn't it? But whereas the remaining two which are given here, the nuclear and the renewable one. So renewable, it means that by using the non-conventional sources of the energy, you may have the solar, you may have the biogas, you may have the biomass, MHD, then the fuel cell, tidal energy, wind energy. So all those are coming under the category of the renewable energy. Even I will say the hydroelectric also is nothing but a renewable form of the energy. Okay. So these two trends, as far as the nuclear and the renewable are concerned, so we see that these particular lines are at the bottom of this graph. There is almost from 1965 to 75, almost I will say up to the 1980. The consumption trend as far as the nuclear energy was concerned, it was almost constant. There is slight rise, slight increase from the 1985 onwards. And from 1985 onwards, it has remained almost flat. This curve can be seen almost flat. So it was flat from 1965 to say 1980. Then it gained slight momentum from 1980 to 1985. And from 1985 to the 2015, this particular trend almost remained flat. So there has been as such no significant increase in the energy consumption trend as far as the energy available from the nuclear sources are concerned. Okay. Then a renewable one, so green. So you can see that this graph is almost flat at the beginning, and it has been just steadily increasing. So from 1985 to the 2005, we can see that the energy that is there from the nuclear as well as renewable. So both the graphs are overlapping with each other, isn't it? So it means that both of these methods of generation have shown a similar trend, similar potential. But from the 2005 onwards, we can see the graph which is there for the renewable one, that is green. So that is deviating from this red one. So this red almost remained constant, but there has been slow and steady increase in the usage of the renewable energy consumption, isn't it? So this pattern is definitely the optimistic one or the helpful one, and we can hope that this particular trend for the renewable, so that will be say moving in the upward direction in the coming days, in the coming years, as this oil, coal, and gas, they are not going to last for years, for more than 20, 25, 30 years down the line. So we have to move there with the alternative one, okay, renewable one, including the hydroelectric also. Okay, so that is what the energy consumption trends across the globe. Now, how much of the energy is generated? Okay, it means that how much of the electrical energy is generated from the various fossil fuels or the different sources. Both are considered here, not only the fossil fuels, but the alternative sources are also taken into consideration. The earlier one, this which is shown here, the energy consumption. So it means that this energy is used there for the generation of the electricity, for the transportation sector, for running different sectors of the economy, for the agriculture purposes, for every sector. Okay, so this energy consumption did not necessarily be only for the power generation. Okay, it is there for almost all the sectors. Whereas this particular slide that shows the worldwide percentage of power generation. Okay, so that is the electrical energy that is produced or the contribution that is made by the different fossil fuels or the different sources which are available to the mankind. So we are having this one: coal, natural gas, oil as usual, CCUS. I will ask all of you just to go through the CCUS. Okay, I will come to that point sometime in the later sessions. But you can just Google out there information for the CCUS, the nuclear, hydro, solar, wind, and other renewable. So one can see that at the bottom of this chart, hydro, solar, wind, and other renewables. So they are represented in the green color, isn't it? So their contrast of that green color may be somewhat different to identify which is the hydro, solar, wind, and other renewables. So that tells us that these are nothing but the renewable forms of the energies. Okay, they are not going to hamper the environment. They are not going to result in the pollution, isn't it? So non-conventional, renewable forms of the energy. As far as the current status is concerned, just year or two ago, that particular trend might have been changed to a very smaller extent. So as far as the this 2018 pattern is concerned, and which is shown in this particular pie chart, so you can see that the major percentage, major contribution, land share is 38%, which is there by the coal. Okay. So across the globe, whatever the total electrical energy is generated, it's still on account of the consumption of the coal. 38% of the energy is consumed by the coal. Then another one, that is a natural gas. So this 23%. So nearly one fourth. Okay, nearly one fourth of the energy is generated by using the natural gas reservoirs or resources. Oil. So very less amount of the oil, that is 3%, is used for the generation of an electrical energy, electrical power, because this majority of the oil is used for the transportation sector. Is that fine? So that's why a very small contribution is there for the oil. And you can see that this CCUS. So in the chart, pie chart which is shown there for the 2018, so you won't see this color or this shade in this pie chart. It is CCUS. It is not visible. It is not covered here. Is that fine? So we'll see that one in the coming session why it is not covered here as well. The nuclear, 10%, very small amount of energy that is generated by the nuclear resources. Hydro 16, solar 2%, wind 5%, and other renewables, that is nothing but the tidal energy, ocean thermal energy, geothermal energy, wind energy, no, not wind, already that we have 5%, and the biomass, biogas. So all that account for the remaining 3%. So we can see that at the current status, say 2018, so 16 plus this to 18, 18 plus 5, that is 23, 23 plus 3, that is 26. So it means that nearly one fourth of the energy consumption, okay, nearly one fourth of the energy consumption is energy that is generated from the renewable forms of the energies. Okay, one fourth renewable, nearly one fourth is there for the natural gas, slightly more than one third is by the coal, and small amount or small role is played by the nuclear and the oil resources. So this is the current one. But what the stated policies, it means that what targets to be achieved by the end of 2040. Okay, some policies, some framework has been made that this should be the trends in the shifting from the conventional sources of the fuel to the non-conventional technology, non-conventional sources, isn't it? the stated policy 2040, whereas it is the sustainable development 2040. So sustainable development is that as the population is going to increase from 2020 to the 2040, so it means that the trends of the consumption, so that will be increasing, ever increasing. So never it will be say, coming down. So to bridge that gap between the supply and demand, so you must have sustainable efforts. So sustainable development has been added as a separate pie chart here in this slide. So let us see this one. So as far as the policies are being stated, policies are framed. So we can see that the role which is they are played by the coal. So energy which is generated by the coal, so that would be approximately 25%. So currently it is nearly 38%. So that would be brought down to around 25%. So 13% reduction is targeted with the policies frame, so that the energy generation by 2040, so that will be only 25% from the coal. As far as the oil is concerned, natural gas is concerned, rather I will say. Natural gas in currently it is nearly 23%, so not much fall can be seen there for the natural gas, okay, 22%. So more or less the same contribution would be there for the natural gas and oil. It is currently 3%, and now it is targeted to reduce it to 1%. Very small amount, because oil is likely to get depleted very fast. So that's why a smaller role, very minor role will be played by the oil in the power generation. Then the nuclear, slight reduction from 10% to the 8%. And the major shift can be seen there on the left hand side. There is the color that we can have in the green in the different shades, isn't it? The hydro, solar, wind, and other renewables. So hydro can be seen currently it is 16%. So by 2040 it is 15%. So not much change is seen there for the contribution made by the hydro sector. But if it is seen there for the solar photovoltaic, solar PV, okay, one of the cleanest energy that is available for us and across the globe. So 2% is currently, so that is targeted to allow around 11%. So more than 5 times the role will be made, would be contributed by the solar photovoltaic, isn't it? So that is nothing but definitely a positive trend that we can see in this power generation. Then the wind currently it is 5%, so that is targeted to be the 13%. So approximately it is tripled there. Other renewables 3% to 5%. Okay, so this 15% plus 11, that is 26. 26 plus 13, that is nothing but the 39. 39 plus 5, so that is nothing but the 44. So nearly half of the energy requirements by 2040 are supposed to be satisfied, or the demand is going to be satisfied with the help of the non-renewable forms of the energy. So one can see that what the potential in non-renewable forms of the energies that would be having. It's a stated policy, and to target there on the sustainable development, okay, to satisfy your requirements at that time. So one can see that the further downward trend is there for the coal, so from 25% to a very negligible or a meager amount of 4%. So almost the consumption of the coal that is going to be say the static one, or it is going to be halt by 2040. Oil, natural gas rather, from 22% to the 12%. Oil almost negligible. So as such, no oil will be used there for the generation of the power. And the 5%, so that is nothing but the CCUs that I was saying, isn't it? So in both these pie charts, the current contributions, the current status, and those are being say targeted, stated policies by 2040. But in actual practice, to meet with the sustainable requirements, sustainable development, the CCU is also taken into consideration. So you find out the information for the CCCUs. I will not specifically mention here for the CCCUs. So that I will keep the task on your side to find out some small information for the CCCUs. Nuclear, 11%. And again, we can see almost 3/4 of the energy requirement. this 18% and this 19%, so that is 37 and this 21, that is 58 and 9, 66. So it means that two-thirds of the energy requirement to be satisfied with the help of the renewable forms of the energy, hydro, solar, wind, and other forms of the renewable energies. So these trends that we can see in the coming 20 years, that is down the line 20, 25 years. So that is definitely there on the positive trend or the positive side, that we can have the potential there for the non-conventional or the renewable forms of the energies. Okay. So this will be helpful for us to tackle the current environmental concerns that we are facing, or the problem that we are facing, uh, the global warming that I will say, and the ozone depletion potential, or the ozone depletion layer phenomena. So all these parameters, all these challenges, problems would be overcome by giving the boost to this non-renewable forms of the energies, as they are possessing the most potential. Okay, so that is there for the worldwide percentage of power generation for the various sources and various fossil fuels. So that is another representation of the some similar facts. So these are the recent facts, I will say. It is when we say compiled there at the end of the 2019. And some similar trends that we can see. Coal that forms around 38%. We have seen that it was 38.3 here. So we can see here it was mentioned. It was mentioned here like that of 38%. It was mentioned here 38%. 2018. So this has been slightly modified. That is 2019 figures are indicated in this particular diagram. So 38% is there for the coal, 38%, 23% for the gas, this one, hydro, this blue color, 16.3%, nuclear, 10%, 10.2%, then the renewable forms, solar, wind, geothermal, and tidal, very small percentage, that we think the 6%, oil, around 3.3%, and the other forms of the energy is 2.3%, thus accounting to be the nearly equal to 100%. Total energy that is produced across the globe, 25,721 terawatt hours. So big amount is there at the global level that we can see. This is another trend. Possibly we'll discuss this particular graph and maybe one more graph that we'll see, and then we can stop for this discussion for the today's lecture, as we are running out of time. Slightly less than 10 minutes are left with us. So this particular graph that shows this bar chart that shows the per capita consumption of a particular country from the various continents, various parts of the globe. Some Asian countries at the beginning, Bangladesh, Pakistan, India, Nigeria, that is the South African, then Brazil, South America, Indonesia, again the East Asian, we will say China, then some European countries, Italy, UK, Japan. Japan is there, Asian. For the European, Italy, UK, Germany, France, in the northern part of the world, that is Russia, and the United States, North America. So these facts have been say compiled maybe some 3-4 years ago. There may be some slight different changes in the pattern for this energy consumption. So need to be updated for that one as well. And if it is in as far as the Asian countries are concerned, the Bangladesh, Pakistan, India, very small consumption of the energy per capita. Okay, 614 as far as the India is concerned. And if the Asian country, that China is taken into consideration, if we compare China, the per capita consumption of the China with per capita consumption of India, so nearly India is 400 and China it is 3 times more than that of India, isn't it? So that is 2000 energy that is consumed per capita energy consumption is there for the China. And if we see there for the European countries, Italy, UK, Germany, and France, that is in excess of 2700, 2800, and nearly equal to the 4,000 kilowatt hours of energy per capita consumption. If you compare our consumption with the United States, the 7,000, and India that is 600. So that is nothing but the 10 times more the consumption is there for the United States. Per capita energy consumption for the United States is nearly 10 times than that of India. So that trend also shows the standard of the living for that particular country, isn't it? So that is bird's eye view for the energy, per capita energy consumption for the various countries. These are nothing but the global consumption trends in the energy units. Okay, in the last 20 years, I will say. Okay, not very big history, but in the last 20 years, from 1998 to say 2016, so 18, 19, 20 years rather. So if we divide this particular graph into the two different parts, say first half part and the second half part, from 1998 to around say 2007. So this first 10 years, and then from 2007 to the 2016, so last 10 years. So we can see that from 1998 it's 44.4, and by the end of 2007 it have reached to the 107.8. So slightly less than 3 times. Okay, so this global consumption of the units has been increased slightly less than 3 times. If you multiply this 44.4 by 3, so it will be around 130. So slightly less than that one. Okay. So 2.7, 2.8 times this energy consumption have increased over the last 10 years from 1998 to the 2007. And if we see for the second part, the next 10 years from 2007 to 2016, from 107 to the 420. So it is nothing but nearly 4 times the consumption have increased. So that is what the trend that we can see in a very short history of the first 10 years and the second 10 years. So in the first 10 years, there was an increase of around 2.8 times, and in the immediately in the next 10 years, 10 following years, so it has say reached to 4 times. So it has been quadrupled in the last 10 years. So that is what the tremendous change that we can observe in the pattern for the energy consumption. And maybe this trend is likely to be expanded or the magnified, multiplied further down the lines. Is that fine? So that is there as far as the today's session is concerned. I will take full stop as far as this particular session is concerned, this lecture is concerned. The other points of the discussion are there, similar trends that we can discuss there for the national level, and analogous discussion can be also had there for the state level indeed. And after completing this discussion onto the national level and the state level, we will be completing the first part of the unit number 1. And then maybe in the next 2 lectures, we can start with the second part of the unit number 1, that is nothing but the economics of the power generation. So if you think that the things are being quite difficult to understand, so let all of you to reach me with the suitable mode. Those are being say available with you. Don't hesitate to ask any help, any question that you need. I am always available there for your help, and I am thankful for your kind attention for this particular session. So thank you very much. I will stop here.